since 1900. The fear is that we could push temperatures to the same levels as 125,000 years ago. The extra 9 degrees will melt enough ice to push sea levels up by 20 feet. So just how fast is the ice melting? In March 2002, climatologists get a wake-up call. Over 2,000 square miles of an ice shelf called Larsen B in Antarctica crash into the sea without warning. One man is not surprised. He makes regular visits to the northern coast of Alaska, to the ice cap at the opposite end of the Earth to check the sea ice conditions. Don Perovich physically measures the thickness of the ice, building up a priceless record of just how quickly today's frozen worlds are disappearing.
If we look at the sea ice cover, back in the 70s was roughly the size of the continental United States. Now it's as though 22 states, almost the entire United States east of the Mississippi, have melted away. If we also look at the thickness of the ice, that ice used to be around 10 feet thick, and now it's decreased in thickness till it's barely 6 feet thick. So you put it all together and it's a substantial loss of ice. If you look at the total amount of ice, it's lost around a third of its total.
Startling satellite images taken between 1979 and 2003 reveal just how much summertime ice has been lost in the Arctic. And in 2007, scientists watch in amazement as thermometers climb from their normal 41 degrees to record highs of over 70 degrees Fahrenheit. The sea ice is a clear indicator of how fast the Earth's frozen continents are melting. But it won't contribute to sea level rise because the ice is already floating on the ocean. What rings alarm bells for climatologists is Greenland and Antarctica. The ice on these continents sits on rock above the waterline. As these thaw, the extra water will flood into the oceans, dramatically pushing up sea levels, threatening coastal cities all over the world. Florida, the sunshine state that boasts over 1,300 miles of coastline. Some of the most expensive real estate on the planet is built on these shores. But all of it could be at risk. By measuring how fast the ice sheets are melting, climatologists can project forward and build a picture of future sea levels.
By the end of this century, right now, the biggest estimates are 3 or 4 feet of sea level. What part of the world will be most affected? I think even North America, the United States, is going to have a hard time with sea level rise. Here's a map of Florida. You can see the shape of Florida here. And it's a green map. It has white areas, which are those that have high density of people. If you just add 3 feet of sea level to this, you get these red areas, which are the areas which get covered up by ocean water with 3 feet of sea level rise. And in some places, the color is actually pink because that's where dense human populations are going to be subject to the sea level rise over property that they own. If you go up, increasing, I'm going to go right up to about 20 feet or 6 meters, you can see the red just expanding northward. And the whole shape of Florida changes. It becomes a much smaller state. The whole coastline, Cape Canaveral, up to Jacksonville, and up in the southeast, is flooded by the ocean if we get that amount of sea level rise.
And it's not just the U.S. that'll be hit hard by sea level rise. European coastlines will be devastated too.
This is the kind of sea level rise that we got 125,000 years ago. So this is not just a model-based projection, it's based on our understanding and our analysis of Earth history.
Overpeck's computer models offer a terrifying glimpse of our future. But it's hard to really imagine just how bad it could get, until 2005. The theory becomes reality. Hurricane Katrina slams into New Orleans, swamping the city under 15 feet of ocean. It paralyzes the population and leaves nearly 1,500 people dead. Is this a glimpse of what could happen to coastal cities all over the world? Many experts believe New Orleans' tragedy could become a global reality within a few hundred years. The flooded world of 125,000 years ago lasts for some 5,000 years. Then 110,000 years ago, the Earth plummets into an ice age. And modern humans first appear on the African continent. Plants and animals slowly adapt to the new, cooler conditions. Until 11,500 years ago, temperatures begin to rise again, and fast. Life faces another fight for survival. The 1-mile-deep ice sheets that stretch as far south as New York are on the retreat, and life hangs in the balance. For 2 million years, huge prehistoric beasts, the mega-mammals, had ruled the lands. Giant sloths, the short-faced bear, woolly mammoths. They thrived during the cooler climes of the ice ages, but rapid global warming now threatens their survival. Evidence of this climate change can be found in ice. Every year as snow falls, it forms a layer of ice on the surface. Over thousands of years, these layers build up one on top of the other. Scientists drill down into the ice sheet layers and pull out cores that contain a treasure trove of climate data that stretches back 110,000 years.
The history of how much was snowed, what the temperature was, where this was collected, what was blowing in from elsewhere, what was erupting, what was zapping in from space, what the position of the atmosphere was. It's all there.
Locked away inside the ice core is the evidence of past climate-changing events. Ash from volcanic eruptions, sand blown in from droughts, and tiny bubbles from ancient atmospheres. By analyzing these particles and gases, scientists build up a picture of past weather. 1990, Richard Alley and his team drill the deepest ice core ever, 2 miles down into the Greenland ice. Alley is studying the thickness of the snowfall layers in the cores, which is a clear indicator of sudden climate change. As he examines the layers, he makes a remarkable discovery.
We're watching the thickness of the annual layers, and it's this thick, and this thick, and this thick, and it's half that thick. And it's boom! It just changed like that, and it's wow, look at this. This is just truly amazing.
The thickness of the snow layers suddenly shrink. It's a sign the Earth's climate and weather had changed, and fast.
Many times in the past, there were abrupt, rapid, boom climate changes that happened. Usually the climate is well behaved, and occasionally something throws a switch, and you're going along, and the switch is flipped, and you've got a completely different climate.
Alley zeroes in on 11,500 years ago and the sudden change in the thickness of the layers in the ice core. He extracts the gases in the minute bubbles locked away inside the ice. The greater the concentration of a particular type of oxygen trapped inside these tiny atmospheres, the higher the temperature at the time. The team calculate that the Greenland ice sheet had warmed by 18 degrees Fahrenheit in just a decade. For the mega mammals, this spelled disaster. 2 million years they had ruled the planet. Now, in the wake of a rapidly changing climate, they face annihilation. Evidence for what happened lies here, in Kentucky, buried deep inside ancient caves. For paleontologist Ken Tankersley, these caves are a dream. They're crammed with fossils, a mega-mammal graveyard. Caves act as Mother Nature's sewers. The rains wash corpses into caves, and over time, layer upon layer of dead bodies build up on the cave floor. Tankersley drives a core deep into the graves of the mega mammals. The deeper he goes, the further back through history he travels. Finally, he's cut deep enough to reach back 11,500 years. The core is full of fossilized megamammals. And then, nothing.
From this point on, no more megamammals. In this sediment, really looking at the extinction point, the end of the last ice age, it's right here, and beginning the last natural period of global warming.
Global warming annihilated the megamammals. Then Tankersley makes one more remarkable discovery. The fossils stop suddenly in the core, so much so that the extinction must have happened within just a few decades. Tankersley's findings match the ice core evidence of a rapid rise in temperatures 11,500 years ago.
Because the last period of global warming occurred within decades, within a human lifetime, the environmental change was so fast that these large animals could not keep up with it, and they did become extinct.
Rapid heating devastates the mega-mammals' habitat. Their food supply vanishes. In the battle for survival, the mega-mammals had lost. Victory would go to the species that could adapt, humans. The hunter-gatherers turned into farmers, cultivating crops and developing tools to clear the land and grow food. Humans had adapted to their new, hotter world. The rise in global temperatures 11,500 years ago had triggered a climatic change so swift, so profound, it gave birth to human civilization. Yet its cause remains a mystery. There are many theories. A shift in the Earth's orbit, superstorms, and the most controversial idea of all, a cataclysmic comet strike. Comets hurtle through space at more than 500,000 miles per hour, missiles of dust and ice many miles in diameter. Most deadly of all, they're armed with a lethal payload, millions of tons of frozen carbon dioxide. If a massive comet did smash into the Earth 11,500 years ago, it would wreak havoc on the climate, could wipe out entire species.
A comet strike in the Earth's atmosphere occurred, and then increased the carbon dioxide content in the atmosphere, leading to a very rapid warming event, one that literally happened within a human lifetime.
If the theory is right, after the strike, temperatures would drop as immense dust clouds obscure the sun. But then temperatures would rise rapidly as millions of tons of greenhouse gases are released into the atmosphere. Supporters of the theory believe only something this powerful could change the climate in the space of just a few decades. Scientists are still hunting for evidence to support the comet impact theory. In the meantime, it remains highly controversial. But whatever the cause, it's clear that the rapid temperature increase triggered an epic battle for survival. That the mega mammals lost, and our ancestors won. With the world today once again facing rapid global warming, will we be able to adapt this time? Or will we suffer the same fate as the megamans? $11,500 years ago, the Earth emerges from the last major ice age. The roller coaster ride of the past is over as global temperatures stabilize. In these milder weather conditions, humans inhabit most regions of the planet. Civilization blossoms. And then 400 years ago, something unexpected occurs. Temperatures drop suddenly. Europe and North America take the full force of the lethal cold snap. Artists capture the bizarre events of the period that would come to be known as the Little Ice Age. In North America, New York is gripped by freezing temperatures. It's even possible to walk from Manhattan to Staten Island over the ice. Winter 1607, the River Thames in London freezes, a phenomenon that will occur throughout the next 200 years. The scenes look charming, but the reality is devastating. Across Europe, crops fail, bringing famine and death to thousands. To the superstitious population, such horrors can only be the work of witchcraft or the wrath of God. And in a way, their suspicions were correct. The cause of the Little Ice Age may not lie on Earth, but in the heavens. The sun. People had been observing it for millennia. But it would take a genius to begin to unravel its mysteries. A genius called Galileo. The Italian astronomer observes a series of black spots, called sunspots, that seem to move over the surface of the sun. He tracks their changes, carefully recording their position over a 6-day period.
You have the disk of the sun on each of these. You have the individual sunspots marked there. And Galileo realized very quickly that he is seeing the same sunspot from day to day as it is moving across the disk. And he saw that these sunspots change in shape.
Galileo didn't fully comprehend the significance of sunspots. His observations were so ahead of their time, it's not until the 1900s that scientists make the link between sunspots and the Little Ice Age. British scientist Edward Maunder studies past sunspot records. He compares the number of sunspots with temperature records and makes an extraordinary discovery. A significant drop in the number of spots between 1614 and 1715, the very time of the deadly cold snap.
Maunder noticed that the sun was almost free of sunspots.
At exactly the same time as the Little Ice Age. It's a major breakthrough. It seemed sunspots had a direct effect on the Earth's temperature. But how? The answer lies deep within the sun's core. Sunspots are dark areas on the sun's surface. But they're created by magnetic forces deep within the sun's core. The more the interior churns, the more loops of magnetic force appear. They change shape, merge, and disappear. The result is a spectacular display of sunspots. Immense hot zones, anything from 3 to 5 times the size of the Earth. The bigger the spot, the greater the magnetic activity that lies beneath.
The sunspots themselves are only a manifestation of the magnetic field of the sun. And what this magnetic field also does, it causes the whole sun to brighten and dim.
More sunspots indicate more magnetic activity, and that means the sun is producing more heat. Fewer sunspots mean less heat. It was this drop in solar activity that most likely caused the Little Ice Age. The sun's magnetic activity goes in cycles, so while it's hotter today than 400 years ago, some scientists predict the sun is set to cool, reducing temperatures on Earth. could this counteract the effects of man-made global warming? Is it the lifeline scientists have been searching for?
If you look into the future, even if the activity of the sun were to go down from its very high level at the moment, and that were to lead to a certain cooling, this relatively small amount of cooling would be totally offset by the very large warming we're going to get from this further increase of greenhouse gases.
Even if the sun cools, the 2007 IPCC report predicts the world is still set to warm a further 3 to 7 degrees Fahrenheit by the end of the century.
What we're doing, though, as humans, we're changing so many things in the climate system that we are pushing it very much faster than nature is. Nature has a very slow push going on that should be changing temperatures by a couple of degrees, maybe a degree over 10,000 years, so a 10,000th of a degree per year, and we're pushing way faster, 10 times, 100 times, 1,000 times faster on many different things.
So despite the forces of nature that might have pushed the Earth into colder times in the past, today the Earth is actually warmer because man has become a force of nature too. The Little Ice Age lasts for almost 300 years, until the middle of the 19th century, when our global temperature line begins to settle down. But then the forces of nature once again push the climate to extremes. 7 p.m., April 10th, 1815. Mount Tambora, a volcano on the island of Sumbawa in Indonesia, erupts. A chunk of rock the size of Manhattan Island blasts into the sky, leaving behind the largest volcanic crater on Earth. The eruption kills 92,000 people, and its effects will be felt across the entire planet. Millions of tons of dust and ash rocket into the sky, eclipsing the sun. Temperatures spiral downwards.
It caused global cooling. The next summer, 1816, has been called the year without a sunlight. There was a killing frost every month in the summer of 1816. Crops that were planted failed, they were planted again, and they failed. And so by the end of the summer, it was hard to get food for the people and for the animals.
The average global temperature drops nearly 2 degrees Fahrenheit in less than a year. A seemingly small temperature change, but one that causes freak weather conditions across Northeast America. June 1816. Gigantic snowstorms hit New England. Lakes and rivers freeze as far south as Pennsylvania. It doesn't make sense. The volcanic ash and dust from Mount Tambora only remained in the atmosphere for a few days. The sun was no longer obscured, yet the cooling continued. Because Tambora unleashed something much more potent than ash into the atmosphere. A chemical formed deep within the magma chamber beneath the volcano, sulfur dioxide. It has the power to cause sudden and dramatic climate change, and can be studied at Yellowstone National Park, the most volcanically active area in the United States.
We're right by these hot springs that are putting up sulfur gases all the time. If it's explosive enough, it puts the SO2 up into the stratosphere. It reacts with water and forms tiny little droplets of sulfuric acid. These droplets get spread around the world by the winds, and this cloud reflects the sunlight and cools the surface.
As tiny droplets of sulfur dioxide erupt out of Tambora, they form a mirror around the entire planet. They reflect sunlight back into space. The result is a sudden drop in the Earth's atmospheric temperature. The lifetime of sulfur dioxide in the stratosphere is just a few weeks, but its impact on the climate can be devastating. And the terrifying truth is that this will happen again.
Volcanic eruptions will happen in the future and will cause climate change. We just don't know where or when or how big they'll be.
But it could be big, very big. Mount Tambora is a baby compared to the mother of all volcanoes, Yellowstone. Yellowstone is a super volcano. Deep below the steaming, bubbling surface is a gigantic lava chamber over 40 miles wide. An eruption here could claim up to 1 billion lives and devastate continents. Over the last 2 million years, Yellowstone has erupted 3 times at intervals of 600,000 years. The last time it blew, the blast covered 3,000 square miles with a 3-foot layer of ash.
If such a thing happened today, it would put so much stuff up in the atmosphere, it would get cold and dark at the Earth's surface. Temperatures would plummet to below freezing, and it would be devastating for agriculture around the world. There would be massive famine and massive death. It would be a giant catastrophe.
The next eruption is now 50,000 years overdue. If Yellowstone blows, it could plunge us all into a devastating nuclear winter. A couple of years after the volcanic eruption of Tambora, the planet recovers and conditions return to normal. But by the mid-19th century, the Industrial Revolution arrives. Coal-fired furnaces spew carbon dioxide into the atmosphere. For the first time, human activity is changing the planet's climate, forcing global temperatures up beyond their natural variations. The destructive power of global warming's new phase is evident on Greenland's glaciers. 2000, a team from NASA set out to investigate just how much of Greenland's ice sheet is melting. Over a 5-year period, they scanned its surface, and the results are alarming. The blue areas indicate where the ice is melting. Some regions are thinning by a staggering 3 feet per year. Overall, the ice sheet has shrunk by 45 cubic miles. It seems the meltdown is already underway, and not just at the polar caps. The world's tropical mountains also show signs of global warming. In his quest for evidence of man-made climate change, Dr. Lonnie Thompson has spent more time above 20,000 feet than any other person on the planet. This is Thompson's ice core refrigerator, running at a teeth-chattering minus 34 degrees Fahrenheit. Over 30 miles of ice cores are stored on these shelves. It's a unique record of ancient weather. This one, from the super-chilled peak of Kilimanjaro in tropical Africa, shows just how fast our world is changing. Thompson's attention is drawn to the top 3 feet of the core, representing only the last 40 years of ice formation.
What is really striking about the Kilimanjaro record is that if you look at the very top, or the upper 1 meter core, it's quite different. And you physically can see that difference. You can see these very large bubbles, elongated bubbles, and you can actually see holes in the ice. Those holes are formed by water going through the surface.
It's disturbing evidence that shows, for the first time in 11,700 years, the Kilimanjaro ice cap is melting. Its melting waters cascade down through the surface and thaws holes in the ice, forming cavities.
Had that condition existed any time in 11,700 years, you would see it physically be recorded in the core, but it doesn't exist. And that's why we think what's happening in Kilimanjaro today is unusual, at least in the history of this record, which goes back 11,000 years.
This is climate change at an unprecedented pace. So rapid it can be observed in photographs Thompson has taken of the 5,000-year-old Calcaya ice cap, high in the Peruvian Andes. Over less than 30 years, Thompson's photographs bear witness to its dramatic transformation, from majestic giant to mighty rock. Thompson's discovery is the smoking gun of climate change, evidence that we are changing the climate beginning to feel the wrath of global warming. Weather is becoming increasingly extreme. Powerful hurricanes strike with devastating force. Flash floods kill thousands of people. But global warming is not just about melting ice and extreme weather. 6,000 miles north of the Peruvian Andes in Alaska, our warming climate is releasing the most powerful greenhouse gases. The last frontier, on the roof of the world. Thousands of square miles of wilderness that have survived unchanged for millennia. The terrain is made up of frozen ground called permafrost. Dr. Katie Walter is researching this super-chilled landscape on the edge of the Arctic Circle. And she's noticing an alarming thawing of the permafrost.
At one time, this field would have been flat, easy walking. Today you have to be careful where you step because there's sinkholes everywhere. Beneath us is a whole network of tunnels. What's happening is that the permafrost is melting, and when the ice melts, the water drains away and the surface of the ground collapses. But it's not just unique to this field. We could go to all over Alaska, parts of Canada, and all of Siberia is just covered with places where permafrost is melting.
Walter uses these sinkholes to access the underlying permafrost.
So what I've got in my hand here are two samples of things that you would find in permafrost. On one hand, ice, frozen water. On the other hand, this is just soil, but it's been frozen. And you can see in the soil that there's a lot of grass roots, a lot of dead plant material that's been locked up and frozen in the permafrost for hundreds or thousands of years, sometimes tens of thousands of years. The entire Arctic, as you go north towards the North Pole, is underlain by permafrost.
Now the permafrost is melting, with devastating effects. Across Alaska, buildings and roads are collapsing into the ground. But this local disaster could become a global emergency. Locked within the permafrost are vast reserves of the potent greenhouse gas, methane. As global warming thaws the ground, it threatens to release the methane and push the world's temperatures even higher.
If all of this permafrost was to thaw and the bacteria were to eat this dead plant material, they would burp out methane or carbon dioxide. We estimate that they could increase the amount of methane in the atmosphere 10 times of what's there today, so very strong greenhouse effect.
In Alaska, methane is trapped underwater. Below the tranquil surface of this lake is a ticking time bomb. Trapped methane gas just waiting to escape to the surface.
We are out here to find hotspots of methane bubbling. Those hotspots are not temperature hotspots, but we call them hotspots because they're really high rates of bubbling. And so what we've realized is that all of this methane, when you add it together, it contributes up to 6% of what's entering the atmosphere each year. So there's a large amount of methane coming out of lakes, which is a fairly recent discovery.
The gas sits trapped in the soft sediment of the lake floor. Using simple equipment, Walter collects methane.
So I'm getting all of the air out of the bubble trap, and then we're going to capture methane bubbles that are coming up. So at the moment, our bubble trap will be just full of water. I'm going to stick a stick down there and cause the bubbles to come up. See on that? Natural bubbles. Beautiful.
And to prove these are not just air bubbles, Walter strikes a match. The gas ignites.
There we go, we lit it on fire.
Walter has collected just a small amount of methane gas, but scientists estimate that the planet's reserves of this potent greenhouse gas amount to a staggering 10,000 billion tons.
There's as many hydrates buried either in the ocean sediments or in the permafrost as there is all of the oil and gas reserves on Earth. So there's a huge volume of them. If they were to be released today, we might experience the type of catastrophic warming that the Earth underwent 55 million years ago.
If world temperatures continue to rise, ever larger amounts of methane will be released. The result, a chain reaction and soaring global temperatures. Since the 1970s, average global temperatures have climbed nearly half a degree. It's a seemingly small increase, but scientists believe it is already destroying glaciers, melting polar ice caps, and thawing permafrost. If this trend continues, we could end up with runaway global warming. Unlike the planet's past climatic crises, the cause of today's warming is human. Our journey through the last 650 million years of the Earth's climate history has taken us from the frozen extremes of snowball Earth, through the scorching temperatures that wiped out entire species, to the flooded Earth of 125,000 years ago. The Earth's volatile climatic past shows global warming and cooling is nothing new. Our climate is unstable and swings between extremes of cold and heat. But through the millennia, one lesson emerges: the awesome power of greenhouse gases. It's a lesson we should heed, because today's global warming is again thought to be caused by greenhouse gases, including carbon dioxide, CO2.
A huge amount of what we see in the history of climate is CO2. More CO2 and warmer, less CO2 and colder. That is, broadly, that's a lot of the story.
Scientists are using the lessons from past climate change to discover whether carbon dioxide is responsible for global warming today, and to predict the climate of the future. They're inputting data from the past: temperature, CO2 levels, volcanic events, methane measurements, even the sun's activity. They use this data to create computer simulations of weather disasters known to have occurred in the past. These simulations turn out to be poorly accurate.
It actually gives us the cold of a little ice age. The sun is a little dim and the volcanoes are just a little bit active and blocking the sun. If we tell the model about humans as well as nature, we add to the sun and volcanoes our dirty smokestacks blocking the sun and our CO2 that we can't see that's up there trapping the heat. The model simulates what happened. It matches the whole history. And the latter part of it is mostly us. We have come out of the natural variability and you can see the human fingerprint.
Confident that their climate simulations accurately mimic the weather of the past, climatologists are using them to predict the future. They add in current carbon dioxide levels, oil and coal emissions from factories, power stations, gases from car exhausts, as well as logging and burning of forests, all the effects of human activity. And the results are chilling. The simulations predict that if we keep releasing greenhouse gases at the same rate, levels of carbon dioxide in the atmosphere could double by the end of the century. Temperatures could rise by nearly 4 degrees Fahrenheit over the same period. The Intergovernmental Panel on Climate Change predicts that at the current rate of warming, our world will change significantly. The ice sheets will melt, and many of the planet's coastal cities could be under 4 feet of water by the year 2100. Tens of millions of people could become refugees, fleeing to higher ground.
There'll be whole nations that are going to go underwater with 3 or 4 feet of sea level rise. Whole nations. And then you have places like Bangladesh, where there's already widespread flooding when you have a typhoon. But that's an area where you'll flood a lot with just a little bit of extra sea level rise.
And this could be just the beginning. If we continue releasing greenhouse gases at the current rate, temperatures could eventually reach levels hot enough to warm the seas, just as they did 55 million years ago. That could release millions of tons of methane buried beneath the ocean floor and catapult the world into a deadly cycle of escalating global warming. Just as in the past, survival will depend on our ability to adapt. Wealthy nations will develop an arsenal of technology designed to hold back the oceans and tackle the rising temperatures. While the technology may be shared with less developed nations, climate change is predicted to hit them the hardest. Millions will starve. Entire populations will migrate to cooler regions. Many fear the mass exodus will trigger wars, with nations battling for what little land and resources are left. But this is not the worst-case scenario. In the past, sudden climate change wiped out 95% of species on Earth. And some scientists believe that another mass extinction is already underway. An apocalypse caused by human activity.
We're living in a period of rapid, profound global climatic change, and we're also living in a period of mass extinctions. This time last year, there were 5,000 species that were alive on the planet that are not here today. The year before that, almost 5,000 species went extinct, and the year before that.
But there is hope. Today's climate crisis is in a large part caused by humans. We are finally waking up to the dangers and consequences of our actions. Political leaders are setting new emissions limits. Without these, our consumption would spiral out of control. But in developing nations like India and China, fossil fuel consumption is rapidly increasing.
When I first went to Beijing in 1984, 2 million people, all on bicycles. I was there 3 months ago, there's 12 million people. 6 ring roads around the city. They're driving Mercedes and Volkswagens, and I'm looking at this and thinking, where's the energy going to come from in the future?
80% of China's electricity comes from burning fossil fuels, and there are plans for over 500 new coal-fired power stations to meet the country's insatiable demand for energy. Many scientists believe China's CO2 emissions will overtake U.S. output by 2010. Today, the nations of the world stand at a crossroads, and they need to act together or face a climate even worse than that of our past.
The thing that's more disturbing to me is not just the amplitude or the size of the CO2 increases, it's how fast they're taking place. We're pumping that stuff up at a much higher rate than we've seen naturally in the past. And that's causing climate to change more rapidly than we've seen in the past.
It is possible that concerted worldwide action could make a difference.
I don't know if this one is easy. Finding a way to generate that energy without affecting the world's climate is not an easy one. But I think we can do it. If we learn to live with what's coming, we will make new inventions, new adjustments, and so on.
I think if you look at the climate change in the future, we have some time. But I think the clock is ticking.
But it may take a major catastrophe before we finally take the necessary action on our changing climate.
What would it take to get us all on the same page? It is a very important question, because it certainly wasn't the heat wave that hit Europe in 2003 that killed over 35,000 people. It wasn't Ivan or Katrina that hit New Orleans in this part of the world. My guess would be something like a Category 4 or 5 hurricane going into either Washington, D.C. or New York that would get us all thinking what it is that we have to do to combat this particular issue.
The last 650 million years of Earth's history provides a stark warning of the impact of climate change. Savage temperatures, melting ice sheets, devastating flooding, mass extinctions. Escalating levels of greenhouse gases once again threaten global warming. Left unchecked, it's a potential death sentence for humans and other species.